Here's a problem that may be a little foreboding just because of the science lingo that's involved, but it actually is your traditional math problem where we give you an equation, we define some input and some output variable, and we give you one of the two and ask you for the other. So here it is. You have this function m of d, and it happens to be a log function, and it gives the magnitude of a star, right? That's the size of the star that can be detected by a telescope of minimum diameter d inches. So the first question that we're going to be asked is to determine the magnitude of a star. So we have to right now wrap our mind around what variable is what. So d, by definition, because it's in the parentheses, is my input. So if they ever give me the diameter, I am to replace d with the diameter. And vice versa, if they ever give me the magnitude, that would be the output. It says this equation gives the magnitude. So what they're saying is this gives us the magnitude. So this is the output. Right? If you plug in input D and work this out on your calculator, you'd get some number, and that number would be the output. And likewise, this would also be the output because the equal sign here indicates that these two things are the same. So D is the input, and my output is the whole notation m of d. Sort of confusing. Once you get used to it, though, everything works fine. So when it says determine the magnitude, they're saying determine the output. Determine the size or the magnitude of a star that can be detected with a telescope with diameter 120 inches. So we're saying that the diameter is 120 inches. We're simply saying plug in d equals 120. So that would look like this. If I replace d with 120, then as it goes, you would have to write the equation out, and wherever you saw a letter D, you would have to put in 120. So this is the log of 120. We're plugging in 120 into the log function, and the fact that there's no base there means that we are to use the common log of 10 on our calculator and round our answer to the nearest hundredth. It was 8.8, and it was add 5.2 multiplied by the common log, that's this guy, of 120, and I'm going to put a right parenthesis there just to make things look neat. So I'm getting to the nearest hundredth. Remember, the hundredth place is the second decimal. Because the digit to the right is a 1, I need not round that up, so it's 19.61. They didn't give me units on the magnitude, so I'm not sure exactly how big that is. So now we're asked the opposite. What diameter? Find d, right? What is the diameter? We're not going to be plugging a number in to d because the question is for us to find d. So d is going to stay d, but what's going to happen is our output, which if you remember it was m of d. This entire thing here is the output variable. M of d, what diameter must a lens be to detect a star of magnitude 17.3, and the magnitude was my output. So this whole set of notation represents the output variable, represents the magnitude. So I would replace that with 17.3. And it would be a little more involved because I have an equation to solve now. So you would solve this equation no differently than if you were to solve, say, this equation. You know, what if it wasn't log d? What if it was a single letter? How would you solve this linear equation? It's the exact same operations, addition and multiplication. So you would subtract 8.8 on both sides. And if you want to do this on your calculator, that would look like, clear this, 17.3. We are to subtract, and I know you can do this in your mind. You got 8.5 on the left-hand side, and then on the right-hand side, of course, the whole point was that this simplifies out. You get 0. So you're left with 5.2 multiplied by the log of d. And now, since the 5.2 is being multiplied, I'm going to divide both sides by 5.2. And on this one, I wouldn't assume that I can do this one in my mind. On the right-hand side, then, this would simplify out. Any number divided by itself is 1. I have no idea what 8.5 divided by 5.2 is. So I'm going to go back to my calculator. The last thing I had on the screen was 8.5. So now I'm just going to hit divide by 5.2, hit enter, and I get the answer to several decimal places. Now what I'm going to do is, let me write that down. For the purposes of the problem here, I'm going to round that to 1.63. In math, when it says round to the nearest hundredth, usually what teachers want is for you to keep all the decimals to the very end and then round your final answer to the hundredth. And in science, they have some other rules called significant digits. Needless to say, to solve this logarithm, one quick way to solve this logarithm would be to just convert it into exponential form. But doing so necessitates that you know the base here is 10. So the idea is, because there's no base, you assume it's a 10. So now this is where you say, well, the base is 10. Visualize the circular thing going on. 10 gets raised to this power to give you this result. So 10 raised to the 1.63 gives you the result of D. So that solves the equation. 10 raised to the 1.63 would be the minimum diameter needed to detect a star of magnitude 17.3. Obviously, if it was a bigger lens, that would work too. So this is the minimum diameter. So if I go back to my calculator, notice that I have the unrounded version of 1.63, and I am now to take 10 and raise it to that power. So I'm going to use my caret key. So now you have a choice between rounding the answer, or what I like to do is press second negative, and what that does is the calculator will use my previous answer and use the full accuracy that it has in its internal memory. So 10 raised to the 1.63 comes out to be, this is where I'm going to round to the nearest hundredth. Since the thousandths place is a number less than 5, I need not round up my hundredths place. So 43.11. And this time I do have a unit. The diameter was in inches. So your telescope would have to have a lens at least 43.11 inches in diameter to be able to see a star whose size is as big as 17.3